perform what we would otherwise do on our system on the cloud. It allows us to perform operations that we would do on our laptops on the cloud or over the internet. And it allows us to perform tasks like what you would otherwise do, like machine learning, data analysis, data science. So I'm talking about cloud computing, what it's all about before we proceed. So cloud computing is a service that allows us to allocate computer resources that we would otherwise use physically on the web. That's basically what it is. So we have different types of cloud computing platforms. We have Amazon, we have Azure, we have and we also have some cloud computing services that are developed by companies. So we have independent cloud computing services. But Microsoft Azure and Amazon Web Services, they are hosted. That is, they have a provider that allows these platforms to be available for people, and these people pay on a monthly basis. So they are not owned by a single entity or a single organization, but they are owned by a group of people that allow these services to be available to the public. We have we have two systems that cloud computing is grouped into. So the first group, we have cloud computing that are owned by individual companies, which are not available to the public. That is private cloud computing services and public cloud computing services. So Amazon and Azure fall under public cloud computing services. Yeah, but just basically everything you do on your laptop or your system, cloud computing allows us to do these or to perform these tasks over the internet. So that is just the concept behind cloud computing. So we'll be looking at Azure. Azure is a Microsoft cloud computing service that allows us to perform these computer-related tasks over the internet. So I'll be sharing my screen so that you can see what I'm doing. Hold on. Can we see my screen? So I'm sure we can see the screen now, right?
Yes, we can. Yes, we can.
All right, thank you. Okay, so in order to sign into your portal, so I have already signed into mine. So the link is portal.azure.com. So let me log out and log in again. I can sign out. So first of all, before you can start to use their services, you must have an account with them. You must have a Microsoft account. It's very important. So you can use Amazon as well. Amazon have their own cloud computing services, but I'm using Microsoft's. So there is no particular reason. It's just convenient. So both of them function alike. Their functionality is similar. So there was no particular reason why I chose Azure. But the course content covers Azure. But I'm equally telling you that you can use Amazon Web Services as well to perform the same tasks. So there's no difference. So I already have a Microsoft account and I can log into my account. Now, it's not just as easy as it looks because you have to create an account first, an Azure account. You have to create an Azure account. So you have to first create an Azure account, first of all, before you can even sign in. So I already have an account and I paid for the service. So like I already said already, cloud computing is tasks that you would otherwise perform on your laptop offline. It allows you to do them over the internet. Now, the reason is because sometimes you might run out of space. You might not have enough RAM to process complex machine learning tasks or complex tasks. So they allow you to they make available resources such as processing speed, ROM, that is your read-only memory, specifically SSD. So they give you softwares that replicate what your SSD would otherwise do on your local machine. They give you RAMs as well, random access memories, to use over the internet. So the reason why cloud computing even exists as it is because they know that not every physical machine or physical computer will be able to perform computationally expensive tasks. So that's the reason why cloud computing exists in the first place. But all the tasks performed on the cloud can be performed on your local machine. Like I said, it's just for scalability. It's just for scalability and for efficiency in handling complexity. That is why cloud computing exists. So you need to create an account. Now, upon creating your account, it will ask you to enter your debit card details. It will ask you to enter your debit card details, and it will deduct a fee. They deduct a particular amount from your card. So you have to make sure that your debit card can be accessed internationally over the internet. So not just within your country, but outside the internet. So they would collect a particular amount from you and they'll give you a free trial, as a free tier, a free plan for you to use in the meantime. Now, they normally give $200 credit. So they give $200 credit accompanying their free plan, upon which, after it has expired or after it has been exhausted, they start to charge you from your actual bank. So that is how it works. So like I said, it's just a paid service for you to use a computer over the internet. That's it. So it's not complex at all. But now the reason why we're using it for machine learning, or why it will be used for machine learning, because machine learning, when you are trying to scale a machine learning model, at some point, the task becomes computationally expensive, becomes very complex in the sense that the data can enter millions of rows or even billions. Now, for those of us who have basic knowledge in machine learning, we know that the more data you feed the model, the more accurate it gets at performing that specified task. So the more data a model is fed, the more its accuracy gets. So now, like I already told you, that cloud computing allows for efficiency and accuracy, something that might be a bottleneck when you are otherwise using your local machine, your computer. It allows you to perform these tasks that are very complex and computationally expensive. When I say computationally expensive, I mean that the resources of your computer, your local machine, might not, when I say local machine, your physical computer, it might not be equipped with the necessary hardware, that is the GPU, the graphical processing unit or central processing unit. It might not be efficient to process these complex tasks. So that's the reason why it exists in the first place. So that's the reason why it's used for machine learning. Yeah, because sometimes, specifically when you're training a neural network, or you are training a deep learning system, or you are performing computer vision, whereby you know that you need so many neural networks, millions or billions, to be able to process and break down a picture into pixels before it can render it as code. So now this is computationally expensive, and some computers might crash handling such complex tasks. So it's very it's efficient and it saves you time using a cloud computing system. That's it in a nutshell. That's what it's all about. But let me show you the environment, how it will look like. So I have already created an account, as I said. and I have already logged in. So let me show you how that is done. Okay. So this is my dashboard. This is my dashboard, and this is the welcome screen. So you see that it first of all starts with, tells you can start with Azure free trial. You get $200 free credit, and you can manage access to smart policies. This is just the dashboard. Now I'll show you different things that it has, just like your normal local machine. So these are all the resources. So resources are an isolated system that allows you to start development in Azure. That's what a resource is. It's an isolated system that allows you to start development. Or we can see that, or we can also say that it is part of the, it's part of the components that make up your cloud computing process. It's just similar to how you have your laptop, you have your processor, you have your GPU, and you have everything working together to ensure that every operation you carry out on your laptop is efficient. So that's what a resource is. It is a component that allows your cloud computing process to be smooth. That's what a resource is. Now, we have Azure Machine Learning that allows us to start machine learning tasks. Then we have storage account that allows us to store. So you can even read the description. It says create a storage account to store up to 500 terabytes of data in the cloud. Use a general purpose storage account to store object data. There's no SQL. So it just allows us to store our data. That's what it does. Then Data Factory, to integrate data silos with Azure Data Factory. The service built for all data integration meets skill levels. So in case you are trying to connect to another cloud computing service like Amazon, this is what we will use. We use the Data Factory to be able to create that relationship between another cloud computing service. So that's what it is. And it also allows us to carry out ETLs. So there's a concept that we need to know. We have data science, we have machine learning. Machine learning is a tool used in data science. Data science is a combination between data analysis and machine learning. That's what data science is. The data science is broader than machine learning. It uses machine learning as part of its objective function. What do I mean by that? We know that machine learning is about prediction, as it's based on available data and historical data. We are trying to predict the future. That's what machine learning is about. And data science goes a step further and also integrates data analysis concepts using data analysis tools like Power BI, SQL, Tableau, and Excel. That's what data analysis is. Now, data science bridges those two together, machine learning concepts and data analysis. Now, there's a concept, there's a construct in data analysis called ETL or ELT. Now, ETL stands for extraction, transform, load. Now, extraction means the source where you get your data from. You extract it from a particular source, and then transform. T means you are changing the structure of your data. You are changing it to a different form. Now, your data might be in the wrong form. It might have some missing values. It might not be properly ordered. That's what the transformation process takes care of. It allows you to transform your data from a wrong input into a proper input, into the correct input. Then load. Load now allows us to transform, that is, take that data, not transform, actually transfer. Because I said that the transform process changes your data from the wrong format to the correct format, and then the load allows us to now take that finished data into the tool that we are going to use for our analysis or extraction, that is for our analysis or prediction, rather. So that's what ETL is. Now, ELT, some tools perform ELT, not ETL. So they first allow you to extract the data, they allow you to load it before they transform. So that's what this data does. Apart from, come on, let me get this. Okay, sorry. So, what was I? Yeah, so apart from taking your data, transforming it and loading it, you can instead load it and transform it. Load it rather first, then transform the data. So I will just tell you the tools that do that. We have different tools that do that. But Data Factory mimics those tools. That is what Data Factory does. It mimics those tools that perform these tasks. Now, an example of tools that allow us to be able to perform ETL is SQL. So SQL allows us to extract data, then you transform the data, you extract data that meets a specific criteria, that is to transform it, rather extract it from the data source. The extraction can be over the internet. You can get data from the internet, or a company can give you data. Now, these data are always represented in CSV files. If they want you to perform analysis tasks, for the most part, these data are represented in CSV files. Now, CSV files are comma separated value files. That's what they are. Then, to get these files, that is the extraction process. You get them from whichever source, either over the internet or from a company, and you load, then you transform it. You transform it. So these now, SQL, we have some online SQL platforms, but SQL, if it's on your local machine, it doesn't do ETL, it does ELT. So platforms that do ETL are Power BI and Tableau, because before you even load your data for analysis, you can transform it. But SQL allows you to load it first before you transform. So SQL doesn't necessarily do ETL. It is Power BI and Tableau that do ETL, in the sense that after you have extracted your data as a CSV file, you then transform that data. That is, you clean it or you change the format. Maybe it was in a wrong format or a wrong data type to the correct data type before you load it into the data model of your Power BI or Tableau. Now, in the case of SQL, you have to first of all extract it. That is the CSV file, either gotten online or from the company that you got a job with, and then you load it into the SQL code base. Then you now transform the data. Then you can now start performing extraction. So that's what data factories do. They mimic your tools that you use for extraction, your ETL tool. Okay. Then the next one is a quick start center. This one says quick start center offers guides, step-by-step tutorials and best practices to help you efficiently deploy. This allows you to quickly deploy Azure services, allows you to accelerate your cloud journey. And we have Foundry. So we don't really have, now the course would center around just these three, actually: Azure, how you can store your data, how you can perform ETL. So machine learning, data storage, ETL. So these are the three things it would cover. So that's it. That's basically it. So this is just an introductory course introducing us to Azure services and cloud computing and what it's all about. So that's what cloud computing is in a nutshell. So you need to create an account. When you create your account, you are going to pay. That is, you connect your debit card, and then they will charge you a fee just to start your free service, your free trial. And after the 200 credit has been exhausted, they would want you to further pay for the services. So pay as you go. So it has a pay as you go service. As you use their services, you pay for it. So that's just basically what it's all about. Yeah, so this class was mainly an introductory class into Azure machine learning. So if you have any questions, you can ask before we close. Yeah, okay. You can speak. I'm listening to you.
Okay, with what you said, You're implying that if I use a very low processor system, like maybe a
Yeah,
Celeron system, for example,
yeah,
that I can do programming tasks like hard tasks that normally or originally it cannot do, but because of because of this platform, this Azure or the Amazon, that I will be able
yeah.
to perform these tasks effortlessly.
Yes, precisely. That's it.
Mm,
That's it.
okay,
That's just it.
okay. Thank you very much.
Yeah, welcome. All right, so any questions? Any other questions? So please don't forget to fill your attendance, please. Fill your attendance. The coordinator will send the attendance to the group. Now, so any more questions before we close? All right, I'm listening. Yeah,
Okay, so yeah, thank you very much.
yeah. Good afternoon.
So, in the course of explaining, you made mention of machine learning, data science, and the rest.
Yes.
What about someone that does not have idea of machine learning and data science? How I I don't have idea at all about these two things,
Okay.
and how
Okay.
would I be able to make use of this service, these Azure services?
Yeah. Okay. So now, as you service does not, now it depends on the tutor and your learning path, the direction as to
Okay.
as to how they decided to proceed. Now, nobody would tell you to start using Azure when you don't have basic machine learning knowledge.
Okay.
Like Azure is just a platform to optimize, that is to speed up your development process. So they already that is there has to be an already existing knowledge about machine learning and data science. So you are expected to know, you are expected to be put through on the knowledge of machine learning and data science before you can even decide to use Azure or any cloud computing service. Because these cloud computing services, they just optimize your workflow. They don't teach you these things from scratch. So earlier on, in the first, because I had the first lecture before this, I said that before you can dive into the field of math, now for people who are very serious with the field of machine learning and data science, very, very, very serious. Now, you don't necessarily have to know mathematics or statistics, but I will tell you that machine learning is, in fact, mathematics and statistics. So if you are really serious, you want to know the nitty gritty, how everything functions, and you want to be well grounded, because I'm very sure that the objectives, our objective is to, that is, most of you guys' objective is to be able to have jobs internationally, not just having the certificate and feeling like, oh, I finished this thing. Like to be able to apply your knowledge to be competitive globally. I'm very sure that that should be the objective, right?
Yes, sir.
Yeah. So if that is the objective, you are expected to know math and statistics. Now, in my previous lecture, the machine learning lecture, I mentioned the topics in mathematics and statistics that you have to know if you want to be a machine learning scientist. So I said linear algebra, calculus. I also mentioned optimization, and I mentioned statistics and probability. Specifically, when we look at inferential statistics, chi-square, stochastic systems, optimization theory. So these are topics that you should know before you can. So now Python as a tool, because for data science and machine learning, Python is the language used. So Python is a tool, and you need to understand the underlying construct of that tool before you can apply it and use it for a data science task or a machine learning task. But it is not independent of knowing math. So Python is just a way that we can be able to perform these statistical and mathematical topics easily, solve problems in them using Python as a tool. You understand? But machine learning, it needs you to have knowledge of mathematics and statistics. And the topics I mentioned are the topics that you should be well grounded in. If you want to be serious in machine learning, you understand? So before you can use Azure, you are expected to have knowledge in machine learning, which involves you knowing the maths, the statistics, and then the programming language needed to perform these mathematical and statistical tasks. You understand? So those ones are they are prerequisites. So they are prerequisites: mathematics, statistics, Python. Now it's not only Python. Python is used because it is easy to understand and follow. But other programming languages can also be used for machine learning and data science. So they can be used. We can use Java, you can use C++. In short, C++ and C language are even preferred in machine learning because of their speed and efficiency. Why? They are closer to machine language, that is assembly. They are closer to assembly language because of the fact that they are low level. So when you write code in them, they are easily convertible to machine language. So any language can be used for machine learning, but you are expected to know the maths, the statistics, and a programming language of your choice before you can now then learn Azure. So Azure is just like something to optimize your workflow. It's not necessarily teaching you the foundations of machine learning or data science. Does that answer your question?
Yes, sir. Thank you, sir.
Yeah.
Okay, and sorry, excuse me, sir.
Yeah, I'm here.
Okay. And during the course of this studies of cloud computing, we're not going to learn the use of Python and so it is already assumed that we have knowledge of Python and machine learning.
No. In the program, it's a workflow. It's a walkthrough. It's expected to be a walkthrough. Nobody assumes anything because they assume that you are starting from scratch. So nobody assumes, like it is not expected to be assumed that you know Python. So that's why I told you that machine learning is a subset of data science. Like Azure is just like the final stage of everything after you have already started from the language, learning the basics of Python, the syntax. So Python is a tool needed for machine learning tasks. What they might assume is that they will expect you to know the basic math, which of course should have been gotten in the university, specifically for math and statistics major. But as you're coming into the machine learning field or the data science field, you cannot just come as a tabula rasa, as a clean slate. There must be some pre-existing knowledge of some sort. That is, you must be knowledgeable on what you are coming to do, right? Right? Like there must be some underlying construct on what you want to come and do. I'm not saying professionally. Are you listening?
Yes, I can hear you.
Yeah, I'm not saying professionally. I mean that now there are some books that actually teach you the math from scratch. That is calculus, linear algebra, optimization theory, statistics, and probability. So this is what you need to be a machine learning expert. This is what you need. These are the maths you need, nothing else. So there are some materials that will walk you through understanding the maths behind it. So the math is what you need to know. Forgetting about Python now or any programming language, they just serve as execution systems or execution tools. They are not necessarily needed to understand machine learning or data science. Machine learning and data science are strictly statistical concepts and mathematical concepts. They are independent of programming. So, and this course is basically practical. It's practical. So there isn't much theory. It's just like an application of what you might have already learned, because most university courses for that is during the freshman year, as a fresher, there are some basic maths you'll be taught. And for those who are computer majors or maths majors or statistic majors, they would teach you these mathematics needed. That is, at some point, they would start to focus on the maths needed for machine learning and artificial intelligence at some point. Then after that, you have the knowledge. Then to now specialize, that's where these tools now come into play, like learning Python and learning Azure. So the only thing that might be rigorously taught or should be rigorously taught is learning how to use the tools to execute this underlying construct. Do you understand?
Yes.
Like learning the tools like Python. I want to use this tool now too. So Python is just a tool. Python does not mean that you are a data scientist or a machine learning scientist. So it just allows you to simplify the workflow. There's no way I'll be writing matrices and calculating determinants and then finding the minor of a matrix, or finding the adjacent, or solving trigonometry ratio in order to see how a neural network works with biro and paper. That would just take my time. But it's not like it can't be done. It can be done, but it wastes time. It's not efficient. So that's where these tools come into play, like Python, C++, C language, or whichever programming language you choose of your choice. You understand? So there is expected to be some underlying knowledge of the concepts behind machine learning. That is what it's all about. It's all about mathematics. And then I'm using these tools to now apply these principles. Do you understand? So it's not mandatory that they will teach you the math behind it. That's what I'm trying to say. The math is already expected to be known from your university days. It's expected to know the basic maths, specifically if you are, and even if you are not a major, even if you are not a math or statistics major, if you want to do machine learning, there should be some background checks on what it entails. Then you now study efficiently. So I think the gap, what causes a problem is the fact that it is not emphasized that for machine learning and data science, you need to know math and statistics. It is not emphasized. All we see these days is efficiency. Efficiency is prioritized more than rigor. So rigor is no longer prioritized. Understanding what you are doing or competence is just how can I finish this task in the shortest time possible. So I think that's where the problem is. So, but normally in a course like this, you are expected to be taught the basic of Python, the tools needed, that is the libraries needed to perform machine learning before you now move to Azure. What I'm saying is that before you even learn the tools, the syntax of Python, or the libraries needed for machine learning before you go to Azure, before you learn Python, you are expected to know the maths behind it, how everything works. So that's what I'm trying to say. But you are going to be taught, or you are expected to be taught everything needed to perform machine learning. That is from learning the language and briefing you about the maths behind it, just a brief overview, not rigorously treated. So no one would treat the math like you will learn in the university. So it will not be treated like that. It will just be touched upon, and at some point they will show you how you can use Python to make it efficient. So you'll be taught Python, if that's what you're asking. You'll be taught Python. You'll be taught how you can use the libraries. You will be taught the math, not rigorously, but to be talked about before you would even get to Azure. So Azure is the last thing, but you'll be taught the Python and the maths.
The thing is that it's just I'm just scared because of this is actually advanced mathematics in a way, because the course I studied in the university has no relation to mathematics. So and
Yeah,
Coming here mathematically, I'm coming as a clean slate actually. Unless I would want to go back to I'm coming
okay,
as
let
a
me not
clean slate.
let me not discourage you. Like now, there are two types of machine learning scientists, right? There are the ones that are research inclined. That is the ones that learn the math behind everything and they want to know how a neural network or a linear regression model functions or a reinforcement learning model functions. These are the ones that are research based. Now, there are the other type of people who are result based. So you are looking for efficiency. Now, these people might not really dwell or know the maths in depthly, but they will know the math in a surface level, which is what you will be taught. The surface level, just having the idea of what is going on, not rigorously, but just the idea. What will be focused upon is how you can implement it. So that is the one that anybody who is serious enough can be able to pick up. So you don't need to know the maths. So if I created that impression, that's not what I intended to portray. I was just trying to differentiate the difference between somebody who is efficient at solving mathematical tasks, that is somebody who optimizes solving machine learning tasks, and the other person who is research inclined. So he studies how the system works and how everything functions. So these are two different individuals. But in the workforce, all they want to see is your result. So I think the former is better. That is, you being able to just understand the basics and then implement it using Python. So I think that is what you guys are actually doing, not the other. So the other one is for research purposes, those who are trying to contribute to the field, and those who are trying to know how each machine learning algorithm functions. So they are not related to what you guys are doing. I'm just telling you from my own perspective what I would do if I was learning like you guys.
Okay,
I
this is
would teach you
understood.
that. You understand? Yes,
Yes,
that's
sir.
it. Yeah, so you're not going to, nobody would go back and start teaching you linear algebra from scratch. No, it'll just show you how it works, like just a surface level, how it functions. And then what will be dwelt upon more is how you can use these tools like Python and Azure to perform this task easily without having to. So they would sandbox or they'll put the complexity in a black box such that you don't need to dwell upon the complexity. What you are focusing upon is the efficiency on how fast the task can be performed. So nobody would dwell upon the math. You understand? So you don't have to be scared.
Okay, thank you very much, sir.
Yeah.
Okay, sorry, sir. Is there any like a resource, any book or something that you can recommend for us to be reading? Like even
Okay,
maybe.
what I'll do, I'll post my books to the group now. So these books are very detailed oriented. So it centers around, I'll post for, so I'm working on the research and I'll post those ones needed, the books I'm using for my research. So these ones, they allow you to learn, like I said, it's math anyway. But what I would do for those who want to make their choice, if you want to choose the research part, or you want to choose the efficient part, you can even choose both if you are so motivated. So I'll post the books for Python, that is getting equipped with Python for data science, specifically for machine learning, two books, and I'll post the mathematics needed, the books for the maths needed for machine learning. So that's what I'll do.
Okay,
Let me
sir.
do that. Yeah, I'll do that. Let me do that now so that I'll not forget. Okay, we need oh, just hold on, I'll send it.
Okay, sir. Maybe while you're doing it, I just want to ask one more question.
All right, all right.
Okay, let's say I'm now grounded in a cloud compute. Like, I want to know how, like, what my role can be in maybe an organization. Like, I've tried researching it. It seems a little bit still ambiguous.
Yeah, that's what most people don't get it. Cloud computing is just your laptop on the web. That's all. That's basically what it is. You're using a laptop on the web. So it's not like a special skill, but you will need to
Okay.
have other skills like machine learning, data analysis, data science to be
Okay.
able to simplify the process of cloud computing. Do you
Okay.
understand? So it's just
Yes,
like
yes, yes.
a it's just like an environment that allows your already acquired skills to be efficient. You already
Okay.
acquired tech skills, even networking. You can do networking on the cloud. So the cloud is just like an online computer, like your online laptop. The reason why it's online is because it makes your work easy. You don't have to worry about RAM, worry about space or speed of the execution of your task. That's just it. So most people don't really get it. So that's just the reason why you need to learn cloud computing. Not like it gives you an added advantage at all. It's just to simplify your process. It's just to simplify the skills that you would have already learned or acquired. That's it.
Sorry, good afternoon.
Yeah, good
I
afternoon.
was going to ask, you said cloud is not like a skill like that, and it's just
Yeah,
like um able to perform something on the cloud.
yeah,
Then when you now have roles like cloud solution architect, how does that now? Because I've used AWS before,
yeah.
and I did a few things with EC2 and all of that. So that's why I don't really understand this. Azure, I'm new to Azure. I've not used Azure before. So when you say that cloud is just like using your skill on the cloud, I need clarification on that, please.
Yeah. That's your EW2 or EC2. You said something about EC2, right? You mentioned something about
EC2,
EC2.
that's Elastic. Yes, yes, Elastic Compute Cloud is like an
Yeah,
instance that
yeah,
you launch your
yeah.
virtual
If you notice,
on AWS.
it's just like your command line. I'm not sure you have observed. It's like your command line interface, your CLI, like your PowerShell or your command prompt, if I'm not mistaken,
Okay,
right?
okay. You see, on AWS, you can launch an instance from the dashboard. Then you can also launch an instance via command line. They have the command line interface that used to do that too. That's how
Yeah,
AWS work. I'm not used to Azure at that at all.
yeah, yeah. But if you notice, basically, to throw the question back at you, what task can you perform on Amazon that you cannot perform on your system normally, apart from it being online? What specific task, that is what tech skill, can you do on your Amazon
Okay.
web services that you cannot otherwise do on your system, minus the online service?
Okay, man. So, like, with AWS, you can use the S3 bucket. You can use the S3 bucket to store your data on the cloud. You can
Okay,
host a server in a VPC. That's to
okay,
control inbound and outbound network. You then on the cloud, you can also in solution architecture, you can, let's say you have an organization maybe that wants to launch something. So based on the modality of operation of the organization, you can architect a solution that secures their program or that secures their product, their web product on the cloud.
okay,
So it's a whole lot of technicality to it too.
okay.
So
So all what you
personally, I
have
feel
said,
like it's its own.
you said,
I feel like that's a skill on its own because the solution architect is not easy to, you know, combine
yeah,
all those instances
yeah,
or cloud services to
yeah.
provide a solution.
All right. But do you know that everything you've mentioned, right? You can do them using SQL. You talked about storing data. One. Now you can use SQL to store data on your local machine. Now, you also talked about something else. I can't remember. Maybe you should repeat it. After the storage of data, you talked about something. Maybe you should remind me.
Yeah, talking about in the S3 now, you can store data. You're talking about like if you've written a script if you've written a code in HTML and
Yeah,
Java and all of that, you
yeah,
can gather them in a file and upload those files, giving permissions. You can upload those files to the S3. Then your website is now live or your code is now live functioning on the cloud. And so
yeah,
it's not just data by data. I know SQL does with I forgot what they call them, relational and non-relational database.
yeah,
But S3 you can also store what was it called? Sites. You can put your site in an S3, then launch it in an EC2 instance, then put it in a VPC, in a virtual private cloud, so that you
yeah,
control the inbound and outbound traffic. So that's
yeah,
just solution architecture.
yeah. But all what you have said is can be basically done without them. So my earlier point was that cloud computing just allows you to do what you can otherwise do on your computer online, because everything you have mentioned is not specific to cloud computing. It can exist on its own as a specified skill, like networking. Even what you talked
Yeah,
about, you see, wrapping your website HTML in an environment so that you can upload it. Even that, you can do
yeah,
that with Docker. Like I'm a web developer as well. When I'm creating my website using Django, I can use Docker as a container to wrap all my code, my HTML, my CSS, my JavaScript, my Python code, and then the server. So even when we talk about AGI, that is asynchronous gateway interface, that is ASGWI, asynchronous gateway interface, I can decide to wrap all these informations in my Docker container. So I can decide to do that and then upload my website online. So my earlier point, I am not putting down cloud computing. All I'm just saying is that the task that cloud computing allows us to perform, these tasks can be done even without cloud computing. So cloud computing just allows these tasks to be seamless and easy for us to do. You understand what I'm trying to say?
Okay.
Yeah, it allows
Okay,
us to
noted.
yeah, so that was my point too. I'm not saying cloud computing can be done away with or it's not needed. It's needed if you want to be efficient and fast. You understand? It allows us to have containers wrap our what we're trying to execute or the different operations we're trying to perform. It allows us to do them seamlessly and easily without having to learn or without having us perform so much context switching. The context switching when you are switching from one task to another task. We don't do this when we are using a cloud computing service. So that's what I was trying to say here. So I get your point.
Okay, thank you, sir.
Yeah.
Okay, so sorry, sir. So there is no there is no rule per se being satisfied in cloud computing alone.
Yeah, and the role is just efficiency. That's what I see in everything from my observation and my experience. Because if you're a networker, you're a machine learning scientist, you can even create your own cloud platform. Because I have a material that I'm actually even trying to build my own cloud computing service as well. So this concept can be built by yourself, but of course you need a server to save your instance on the web so that people can use your services. So it's just a collection of different skill sets put in one, hosted on the web. Yeah, so but if you're a cloud computing, if you are someone who's into cloud computing, you are expected to know a skill. That's the reason why when you go on cloud computing, you always see a reference to an already existing skill set, like a data engineer, of course, which we know entails you to be someone who knows how to use a relational database or an RDBMS, a relational database management system, or we see something akin to machine learning, or we see something akin to a server, like what he mentioned, hosting websites online. So you can use these cloud computing services to host your website. So if you are a cloud computing expert, you need to specialize in a skill so that you can be able to make that skill efficient. So cloud computing is all about making an already existing skill that you possess efficient over the internet without you having to lag or having to encounter problems. You understand? So it's all about making an already existing skill efficient over the internet. It's not like it's a new skill entirely. It's a skill because you are learning it. You are learning how to perform these your tasks or this your already learned skill over the internet. So provided that it wasn't apparent before, like you did not have any existing knowledge about it before, and then you now had knowledge on it, means it's a skill actually. What I'm trying to say is that it is not a skill. It's not like so when we talk about skills, so there are skills that solve a particular problem, that is, they solve an underlying construct. Cloud computing creates for efficiency. It doesn't solve an underlying construct. You understand? You use skills that you've learned on the cloud. You use all these different skills you have learned on the cloud. So the cloud is just like a platform that makes already learned skills easier to use or more efficient. So you're just applying the skills you have already learned on the cloud. It's not like the cloud is a particular skill that you're learning. It's just like a platform. And of course, how to use the cloud is a skill that you need to learn. You need to learn how to use the cloud. But learning how to use the cloud in itself is not a skill. It is just like a platform to make your skills, your already learned skills, efficient. You understand what I'm trying to say?
Yes.
So that's I had linear algebra. I'm trying to look for it. Because without linear algebra, you can't do machine learning at all. It's like the foundation of machine learning to understand the construct behind it. Yeah, but I already sent the book, or rather, I've already prepared the book for using Python for machine learning. But I'm just looking for that linear algebra for learning the maths behind it.